folks. Good afternoon. We are today talking about 7-point ratios and proportions. A ratio, by definition, and this is my definition, is a comparison of two or more like amounts by division. That's what a ratio is. Two examples of ratios can be written like this. 3:4. That's read as 3 to 4, or just 3/4. Notice that to go from a ratio written with the colon into a fraction, the first number goes in the numerator and the second number goes in the denominator. Right? Now, folks, there's an important phrase here, and that word is like. They have to be like amounts. Okay? If they're not like amounts, then they're not a ratio. Right? Now, ratios are always written in simplest form. Ratios are always written in simplest form. Okay. All right, ready? All right, so let's take a look at what I'm talking about here. Folks, I have two ratios written on the board. I have two fractions written on the board. One of them is a ratio, the other one isn't. I've got 4 LBS. What does LBS stand for?
Pounds.
Pounds, and 24 LBS. First and foremost, this is why a ratio has to be a ratio, why they have to have like terms. Folks, pounds on the top can cancel pounds on the bottom. Everybody see that?
Oh, yeah.
That's why ratios can never have units. They can never have units. Okay? Now, can 4 and 24 reduce?
Yeah.
Into what?
6.
1 and 6. So that's a ratio of 1 to 6, right? Does that make sense? Okay? All right, so this is a ratio in simplified form. Notice that the units must cancel. And that's why the ratios units have to be like units. If they're not like, they don't cancel. Ratios can never have units attached. Take a look at the next one. I've got 3 inches over 3 feet.
Ooh, not a ratio because units can't.
Would you read this is not a ratio because my units are not like?
Yeah.
Can I change them into like units? Yeah, it's always easier to take the bigger unit and change it into the smaller unit. Aren't feet bigger than inches? How many inches are in a foot? 12, right? So if I wanted to rewrite this, that's 3 inches over how many feet with how many
36.
inches with 36 inches are in 3 feet. Does that make sense?
And then it'd be 1 over.
Now can't I cancel out my units of inches?
1 over 13.
Does that make sense? Right? And then that reduces to 1/12. Does that help me get 1/12?
Yeah.
Now that's my simplified ratio. All right. Are there any questions on what it takes to be a simplified ratio?
Oh, they were wrong. They said on the announcements today that there's not going to be rain. It's going to keep us.
An extended ratio. An extended ratio is just a comparison of 3 or more like amounts. For example, 3 to 4 to 8. Now notice, I could make 3 different ratios out of this extended ratio. Who can tell me one ratio? Tyler?
3 to 4.
I could go 3 to 4. What else could I do, Carla?
3 to 8.
I could go 3 to 8. What's the other one I could do? Sammy?
4 to 8.
4 to 8, right? Now, in this last one, would you agree 4 to 8 is the same thing as 1 to 2, isn't it?
Yeah.
Right? Now, why didn't I write that earlier like that? Well, because can 3, 4, and 8 all be reduced by the same amount?
No.
No. Because of that, that's why you don't simplify this. Now, once you split him up, you can reduce that to 1 to 2. Okay? Now, we've dealt with this extended ratio before, correct? Yeah? You want to redo another example with that extended ratio? You guys try and do this. So, I'm going to draw a triangle to do this problem. All right? Now, I know the ratio of these 3 angles is 3 to 4 to 8. So, Carla, how can I do... By the way, your nails are wonderful.
Con has admitted that he's
All right,
a girl.
Carla, what can I do in this picture according to this ratio?
You can put 3 x4 centimeters.
And it doesn't matter where they go. It doesn't have to be drawn to scale or anything. In fact, if you look at this drawing, 8x is going to be my biggest angle, but in the picture, it's definitely
X
not
equals
the biggest angle. Right? All right, so using the triangle sum, what equation can I write?
3x plus 4x plus 8x.
Lovely. 3x plus 4x plus 8x equals 180. So a little bit of 15x equals 180. Dividing both sides by 15, I get x equals 12. Okay? What do I have to do next, Danny?
Multiply x by.
Right? Multiply the 12 by each number inside of here to get the angle measure, right? So I get 3 times 12 to get this angle, which would be 36 degrees. 8 times 12 to get this, which would be 96 degrees. And 4 times 12, which is 48 degrees. And again, if you added up all 3 of those angle measures, you should arrive at 180.
It actually is.
Are there any questions on this?
Oh wait, never mind.
No. The next thing is a proportion. A proportion is just an equation relating two ratios. In other words, it will say fraction equals fraction. Okay, an example of a proportion would be something as simple as 1 over 2 equals 3 over 6. 1 over 2 equals 3 over 6. Now, the next thing we want to look at are properties of proportions. Okay? The properties of proportions are going to be rules that will help me work with proportions. Ultimately, our main focus for proportion is to solve them. Just seeing who's paying attention.
Why? Just because?
The first property, and this is the most famous one, you know this property. This one is called the cross multiplication property.
English, please.
Okay?
Can we just put multi? I'm gonna put multi.
All right, here's what this proportion says. The cross multiplication property says that if I have two fractions, a over b, and that equals c over d, I'm allowed to multiply along the diagonals.
Oh boy.
Now, the first diagonal right here, these two numbers here, the a and the d, they have the name extremes. These are called the extremes of your proportion. The word extreme means outmost, right, or utmost, right? Would you agree the first letter I wrote is A and the last letter I wrote is D? So these are the extremes of my fractions, right? The first number and the last number that I wrote, correct? The two numbers in the middle, the B and the C, those diagonal are called the means of my proportion. The means. Okay? The means. Now here's what the cross multiplication property says. If I multiply the extremes times each other, A times D gives me AD. That will equal the means multiplied by each other, BC. Okay? Now, just as a proof, who can give me a true proportion? Who can give me a true proportion? A what?
1 over 2 equals 3 over 6.
I love that. Good example. All right? If you look at the example we did up above, we know that 1 over 2 equals 3 over 6. Well, if I cross multiply these two proportions, would my answers still be equal to each other? What do you get when you multiply these two
6.
extremes? 1 times 6 is 6. When you multiply the two means, 2 times
6.
3 is 6. Doesn't 6 equal 6 still? Right? So the cross multiplication property is very handy. Right? Now notice, what I get are equal, but they don't equal what they began with, right? So what's the purpose of having this property? Why do I even care about this cross multiplication property? Ladies and gentlemen, would you agree the beginning problem started with fractions? The cross multiplying, what happens to the fractions?
It's a number.
They get rid of fractions, doesn't it, right? Cross multiplication, folks, this is a great way to clear fractions from an equation if you're solving it, right? Doesn't this get rid of fractions? It gets rid of fractions. which is really helpful to you. Okay.
That way it was
All right. So the cross multiplication property says you can multiply the extremes, multiply the means, and what you get is still equal.
enormous boss turvy.
Topsy-turvy. Topsy-turvy is a rule that we can use. Here's what it says. If I start off with a proportion such as A over B equals C over D. Topsy-turvy means upside down, right? If your world is topsy-turvy, things are upside down. Here's what this says. If I take the left fraction and flip it, B over A, I can flip the second fraction, B over C. That's the topsy-turvy.
I'm gonna go call
Let me now give you an example of topsy-turvy. If I give you 2 over 3 equals 4 over 6. Does everyone agree with this proportion?
Yes.
Yes. You do not agree, Sandy?
Stop.
Or are you just shaking your head in insolence?
You sound like my dad.
Does everyone understand that 2 over 3 equals 4 over 6? Yes. Flip this first fraction, what would it become?
3 over 2.
3 over 2. That's what we call 1 1/2. So that's why that's 1 1/2. Flip this fraction.
6 over 4.
6 over 4.
One
Does 6
and a
over
half.
4 reduce? What did that reduce to?
3 over 2.
Doesn't that reduce to 3 over 2 still? Folks, would you agree that these two fractions are equivalent still? Topsy-turvy says if you want to flip a fraction, you can flip a fraction on the left as long as you can flip it on the right.
Okay, can you stop talking like that? It's really annoying.
Now, how can this be helpful to me? If I had this example to solve, if I want to solve for x,
Oh my god, this kid.
if I give you this equation, 1 over x equals 5 over 2. Now, you could cross multiply to solve. However, there will be a quicker way of doing so. Danny, apply topsy-turvy for me. X over 1 equals 2 over 5, right? Well, wait a minute. What's x over 1? Yes, it's x. And we just solved for x without having to do all the cross multiplication. Correct? Topsy-turvy.
Can you?
Okay, the next one is the old switcheroo. Here's what the old switcheroo says. If I have a proportion that says A over B equals C over D, right? What are my extremes in this problem, Sabra? What are my means?
C and D.
Yeah. The old switcheroo says you can create 2 new proportions. I can either switch the extremes with each other. If I switch the extremes, I would get D over B equals C over A. Does that make sense? All I've done, notice, is switch the place of the 2 extremes. Right?
So funny.
Or, if I had A over B equals C over D, I could switch the 2 means. A over C is equal to B over D. Everybody see that?
Can you not do both?
You could do both. If you did both, that would just be
Same thing.
topsy-turvy. That would be topsy-turvy, okay?
Like your
Alright.
family.
Do you want to look at an example of how this is true?
No.
Do we want to look at an example of how this is useful?
I should.
Yes? All right, take a look at how, again, folks, we're using these properties to help me solve. In this example, if I wanted to solve this equation, all right, if I gave you 21 over x equals 42 over 5. Okay, how would I do this typically?
I got you.
What would I typically do?
Oh, topsy-turvy.
Oh, you can do 5x equals
Ooh.
42.
Would you
Topsy-turvy!
typically, well, if you did topsy-turvy, that would just give you x over 21
21.
equals 42 over 5, equals 5 over 42, right?
Cross multiplication, but
Yeah, I can do cross multiplication. I go 21 times 5,
But
and then 42 times x, right?
But that's harder, so you should do old switcheroo.
Let's do the old switcheroo. If I switch,
Are you from the West?
if I switched my extremes around, if I switch these two numbers with each other, what would my new proportion say?
5x.
5 over x equals
2.
42 over 21.
And it's 2!
Folks, take a look at why this is so much easier now. What do you notice about 42 over 21? Doesn't that simplify? What does that simplify to? Wouldn't it to be 5 over x equals 2 over 1? Now watch how much easier it is to cross multiply. When you cross multiply, what do you get? 2x equals 5, so what's x? 2.5 or just 5 over 2. Did you see how switcheroo? Now, do you have to go through that? No, these are just helpful aids in solving the equation, right? Are there any questions there? All right, last one. All right. Folks, ladies and gentlemen, bottoms up says this. If I have a proportion such as a over b equals c over d, bottoms up says you can take the bottom of one of the fractions and either add it or subtract it to his top. So what's the bottom of the first fraction? B. If I add that to the top of the numerator of his fraction, I'll get a plus b over b. Notice the b still on the bottom. I just added the bottom to the top, right? I can do that as long as I do what? I add the second fraction's bottom to his top. C plus d over d. Yes? Now, could I also have subtracted it? Sure. If I had a over b, I could take a minus b over b is equal to c minus d over d. Does anyone tell me about this?
Oh, wait a second. No, the bell rang. It's 35.
Is it over?
Hey,
All right. And that's it.